We got less time today. Get going. We have less time today.
At least if we have a quiz time today. I was like, what? Quiz time. Sorry.
Going all the way through March 1, early out, white day. Early out. So it's scheduled to go through March 4, March in the main line. Seniors, make sure you log into Google prior to Wednesday, March 15th, and go to the speaker. Students that express interest in that are all listed. Yes, sir. Please close at 3:15, Wednesday, March 15th, that's the day prior. Right. All students are up before Friday, then it's time to get a lunch light restriction this Friday. Dinner is Nora Zola. Junior boys that receive B-Boy Day invitation. Submit your application to every board day. The deadline was extended. If you need to be interested in boy day this summer, close the meeting today. This is Walter. Good. That's the pleasure. Have any questions? Stop in your hand. You can count the meeting Tuesday, Thursday, tomorrow over lunch machine from all council members. 10 tomorrow. PSA meeting. It's major today. Seniors, stop in the county office. If you've not already done so, you are on ballot list. Congratulate our senior March students of the month, Karen Ball, Logan Brewery. Congratulations, all of you. So please stand for the pledge. Please, give a clap. Oh, have a great day.
You didn't do that. No, yay. What? I can take my test next week. Oh, I'm talking about a history test. I'm excited to take a history test for once. I'll take my next test. Can I do that tomorrow during time? Anyways. So I meant to do it yesterday during springtime, but then I had to go to a junior prom meeting. Oh, sorry, you're doing your day quiz. Good work. That was a very talk. What? I'm ready to roll up.
There's 10 minutes, should be plenty, right? Still see some pens going furiously. Let's see what we got. Wake up, Frank. Stage 1, square but not like freshman. Getting x plus 1, 1 plus, multiply and double, 2 of those radicals, plus the radical squared is just the radicand, 2x minus 12. I see a radical now instead of 2, so I'm going to isolate that one. I'll subtract 2x. 1 minus 12 is negative 11. Negative 11, add it over, get plus 12. Now I could divide by negative here before squaring if that just makes it more comfortable. I could have moved the radical to this side and the other stuff to the right side. You got choices, but it's all going to shake out the same after you square it. When I square both sides, I will get x squared minus 24x plus 144 is square outside, square inside. Distribute and start moving stuff over. If I subtract 8x, got negative 32x. If I add 48, we got, what's that, 40, 180, 92. And you solve that quadratic however you want. Maybe you look at the number 192 and you're like, nah, not doing it, and go straight for quadratic formula. Okay, that works. Could complete the square, but it is factorable. What factors of 192 add up to negative 32? Okay. X minus 8, x minus 24. Getting two answers. Those answers are 8 and 24, but need to go back and double check them. If I plug in 8, 8 plus 1 is 9, square root of that is 3. If I plug in 8, 2 by 8 is 16, 16 minus 12 is 4, square root of 4 is 2, 1 plus 2 is 3. Yay, it works. But if I plug in 24, 24 and 1 is 5, yay. Or 24 plus 1 is 25, square root is 5. 24 by 2 is 48, 48 minus 12 is 36, square root of 36 is 6, 1 plus 6, last I checked, is not 5. So, bye-bye. Process. It's all about the process. Did you square correctly, not like a freshman? Did you isolate your radical correctly? Because sometimes we goof moving terms back and forth. Did you square correctly again, not like a freshman? Did you get to the quadratic and its solutions, however that was done? Okay, you might have completed the square, you might have quadratic formula, you might have factored, however you did it. You got to the potential answers, but then you actually checked them and got rid of the extraneous solutions. Now, if you goofed up anywhere back along the way, anywhere above red, if you goofed, that domino affects the whole thing, right? If that happened, did you take it all the way to the end zone, get two numbers that weren't 8 and 24, but you checked both didn't work, so you said no solution? Okay? So if everything went awry on you and you still tried to say this is my answer without saying no, these are not solutions, then we're going to talk about 2 off or 3 off. Okay? I got no problem with you making a mistake up here, running it all the way to the end and then checking your answers and saying both are extraneous, no solution, because based off of the information you had, that would be the correct result. Okay? And I just hand back yet another test. Hopefully you see that is what I'm doing when it comes to the tests. Like, you might have the entire problem is wrong because you missed a negative when you wrote it down. I'm still only going to take 1 off for that if everything afterwards followed correctly. Okay, give you credit for the stuff you're doing right, not punish you for a domino effect. Questions about this? The homework was just 3 problems of practice with this. I assume that after practicing a few times, we're fine with this now. And just because it was in the same lesson, it was other types of equations, I threw in some absolute value stuff just to see if you remembered. Did we? The short version. The short version is you always want to absolute value by itself. You want to isolate the absolute value because what is absolute value? Distance from 0. So when I set this equal to a number, well, say I have absolute value of junk equals 5. That means it could have equaled 5. I can spell. But it could have also been on the dark side, its evil twin, where that stuff would equal a -5 because both of them are 5 units away from 0. So you just solve them both. Okay. The one that had multiple absolute values in it, you notice what was inside the absolute values was the same. So you just bring them over to the same side and combine like terms, put a coefficient in front of it. So just saw the opportunity on there. I only needed a few radical problems to practice. And then while we're there, hey, do you remember this stuff? Okay. All right. This class did leading term test, right?
Yeah.
Oh, the other class was, we're like perpetually 5 minutes behind you. And it's just something happened like 2 weeks ago, and now they're just always one example behind. But, so we got this done. Actually, by test scores, they are. No, they get through the material faster, but they ask more questions. And y'all know what happens in a smaller class, you get more of that individual attention. So they have only 8 kids in there, like one of the smallest classes I've ever had. So they get to ask an awful lot of questions and get clarification that in a larger group, maybe we're not comfortable asking. So
Why did they just put them all in one class?
we were right on the edge. Like today, we're talking about section numbers for next year and how many to build and all that. When we did the schedule last year, we were right on the edge between 2 or 3 sections of PreCalc. If they would have added 2 kids, I literally would not have had space. Like it would have been 2 classes of 31 kids. And I just physically don't have the room for that. I got exactly room for 28 by the tables, and then I can bring in another one and just shove my desk in the corner if I have to. I didn't have room. So we erred on the side of caution and we went for 3 sections. And then naturally there's always a handful who are like, oh, my GPA, and they run away. So I got a class of 8 kids. So, next year though, we already got like 90 some registered. Big class. Because current sophomores is like a 220 class. Current freshman is like a 220 class. So now you have all of them bumping up into that sophomore junior range. Yeah. I think your class is like 180. 180. Yeah. We've been pretty standard about 180 per class, give or take for a while. It's just we've got this block of about 5 classes that are huge. And then after that it dips back down. So well, back up about 15 years and let's think about what was happening. Oh wait, that was the economic collapse of 2008. So that means there was a bunch of people who didn't have jobs and who were at home and they were bored. So we're going to talk about leading terms and we're going to talk about leading terms and zeros.
Hold on, that doesn't make sense. The baby boom economy was doing great.
No, it wasn't. 2008? That was the housing market collapse, dude.
I mean, like 1950, like the baby boomers.
Yeah, but they also did a lot of very stupid stuff and died from asbestos. So, We've talked about this part before, that a 0 is a solution, is a x-intercept, is a root. They're all talking about the same thing, they're just talking about it in different contexts. Okay? If I say that something is a 0 of, so like right here, this is at the point c comma 0. Well, it's an x-intercept because it hits the x-axis. It's also a 0 because the y is 0. It's also called a solution because that's how I find them. I set the y equal to 0 and I solve. And then the factor of it, sometimes also called the root of it, is always x minus that 0. Ahoy. Roger that. Will do. Okay, yep. LaCroix's room again. So, the big thing here when we say x minus c is a factor, again, y'all are spread all over the map, where everyone in here came from 3 or 4 different Algebra 2 teachers. So I don't know exactly how you wrote this out, but if I said something like this was at 6, 0, I would know that x minus 6 is one of my factors, right? Pretty straightforward. But then it's going to get ugly. What happens when instead of 6, 0, it's at 2 plus 5 squared of 3, 0? Because sometimes we solve, like by a quadratic formula or something like that, and we get a compound number like this. Again, compound number is rational part, irrational part. If I want to write x minus the 0, that is x minus the 0. Okay? So even if the 0 itself is ugly, I can still do x minus the ugly 0 to write out my factor. Cool? Now, this is how I would start writing it. Y'all remember construct the quartic that has these complex zeros? And you'd have to go distribution bonkers on it. Okay? It's coming. We're going to do it again, except it's going to get uglier. Okay? We would have to distribute this negative into the compound number and then start distributing for the rest of it. So just be aware, you big kid now, we're going to get deep into some algebra in the next couple sections. Okay? I mean, if that was your jam, if you're one of those kids that's just like, let me just multiply and add letters and numbers all day. I don't want to think, just let me do that. Then you're going to like this. Okay, first one, talk about the graph parts of them. If these are the zeros, it's always the graphic. If these are the zeros, then they're also going to tell me where the x-intercepts are on the graph. They allow me to shortcut the graph itself. Oh yeah, we already did that part. Zeros of the thing. Determine the zeros by factoring. Oh yeah, we're going back down to Factor Town. Do we love factoring when they're cubics, quartics, and quintics? Okay. We always say in week 1 of this class, and that's always why we have those 2 or 3 kids drop in the first week, you better be able to quadratic or you're in the wrong room. Because we've been doing quadratics, Algebra 1, Geometry, Algebra 2. Algebra 2, the quadratics started getting nasty. We had compound and complex roots. So you got to be able to quadratic. We're going to start out with baby steps. State the number of possible real zeros and turning points of this, and then factor it. So first up, how many zeros could it have? 3. Okay. The possible real zeros is going to be 3 because it's a degree 3. In fact, you learned the fundamental theorem of algebra that says it has to have 3 complex zeros. They might be real, they might be imaginary. We don't know yet. Okay? It's kind of like if I ask Owen, how many friends do you have? And he says, I got 3 friends. We got my one real friend, and we got Bing Bong and, SpongeBob over here. Okay? He might have imaginary friends. We still got 3 friends. Okay? What about turning points? When we say it possibly has 3 real zeros, that's because if I take a cubic like this, that's got 3 real zeros, right? It hits the x-axis 3 times. But then it might have 1 real zero. But then it might have, do you remember this? How many is that? It's still 3. When it bounces off the axis like a parabola, it means it happened twice. It was repeated. Okay, so it still has 3 zeros, it just repeated itself. This, because it potentially has 3 real zeros, it has potentially 2 turning points. The extrema. The turning points is always 1 less than your possible real zeros. So my possible turning points, 2. And then it says go and find the actual zeros by factoring. So what is the first stop on the factor train? Always take out your GCF. And thankfully, this is nice and easy. Well, factors of 6 add up to -5. X minus 3, x minus 2. I swear the number 6 just messes with kids in quadratics. Because if that was a -6, then what is it? -6, +1. I don't know what it is about 6, but 6 just messes with kids when you do quadratics. They'll do basic arithmetic wrong so frequently. And then, to actually solve, you set each equal to 0. If I set x equal to 0, I get, well, just 0. If I set this equal to 0, I get 3. If I set this equal to 0, I get 2. So I say x is this, this, and this. Technically, it's a set, which would have been the first place you probably saw set notation in Algebra 1. You don't have to write it with squiggle brackets on there. I said, as long as it's squiggly and doesn't look like a 3, I don't care. No, I'm saying that's what it technically is. If you just write x is 0, 2, 3. All right. Who's the really particular person in here who has to write out x equals 0 and x equals 2 and x equals 3? Okay. You don't have to go that far. So, for each of these, I want to see on 3B who remembers. I want to see who remembers. Most of you are coming straight out of Algebra 2. So you did this like 3 months ago.
Oh my god.
A and B, let's see what you got. Yeah, both of them. Yep, 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 yep. Yes.
Oh, right.
Remember to do the first part of it too. How many possible real zeros? How many possible turning points? Then factor and tell me the zeros. I know that it says find the real zeros by factoring. Nah, we're big kids. Go find them all. Real or imaginary, rational or irrational, I don't care. Find them all. Always one less than the degree. Because for it to have that many zeros, it had to have changed direction one less time. It's the American versus British English kind of thing again. In British, UK English, it's OES. In American English, it's usually OS. Yeah, zeros. You didn't talk this much last semester. I want to see if you remember how to factor part B. Argue it out with your neighbors. What else? For the veterans, remember, it looks like a duck, it quacks like a duck, turns out it's a platypus. Okay? You can treat it like a quadratic, but you have to change something. Go talk to Rachel. She got the light bulb there. So, come on now. What we got? You do the same thing. You write x squared instead of x. Because it's in quadratic form.
Yeah, because it has the 4, 2, 0.
You may have seen it as the U method, where you would replace them. Smiling? Okay.
Yeah, because you go like
Well,
check it, and then you like put your numbers.
you had McCreary, didn't you? Really? That sounds like a McCreary thing. Okay.
Did you just do 8x then? Wait, I don't actually remember that. No, I didn't.
You would treat it like that, but then when you get to your binomials, they're x squareds instead of x's.
Is 27 a prime number?
No.
I don't know what you're saying.
Oh, that's what I meant to. Well, I got this next
So get here so you can x and then x squared and then x.
Don't work that way.
Don't do it that way.
It don't work that way.
You don't work that way.
You can't take an x out if this guy doesn't have an x.
Oh, that's right.
Remember, you got to be an equal opportunity bully.
Square.
Now, you're right about the whole factor thing. Like, factors of 15 that add up to -8, right? But what's the only way x times x is not x to the fourth? X squared times x squared is. And now you'll have -3x squareds. -5x squareds is -8x squareds. It's called quadratic form. It looks like it. And now you got to deal with those. However you do it, you can set an equal to 0 and solve. You can factor by difference of squares. Whatever you want. All right. So either we remembered our training or we blanked. So this guy. First up, GCF. Next up, factor the quadratic. That's a x minus 9, x plus 3. And I would say x equals 0, -3, and 9. There are the possible real zeros, 3 of them because it's a degree 3. The possible turning points is going to be 2. It's always 1 less. 3b. Okay, the possible real zeros and possible turning points of a quartic. 4 and 3. Okay, it looks like a quadratic in the fact that I have a constant here, and my middle term is exactly half the degree of my leading term. That is quadratic form. This could have also been x to the 6th minus 8x to the 3rd plus 15. This could have also been x to the 20th minus 8x to the 10th plus 15. Okay? As long as it's constant, middle term is half the degree of the leading term, that's what a quadratic looks like. So it looks like a duck, it quacks like a duck, and then you go and start carving, and it turns out it was not a duck. It's a quadratic form. You know, maybe it was one of those, what's the stuffed in thing? Turduckens. Turduckens, right? It's a turkey stuffed with a duck stuffed with a chicken. It's like one inside the other inside the other. No, it's not. Y'all, you treat it just like a quadratic. What factors of 15 add up to -8? Okay. But I'm never going to get x to the 4th by multiplying x times x. It's x squared. Now you may have seen, hey! Y'all, come on now. You may have seen this. You may have seen this as the u method, where you'd say u is whatever your middle term is, and then you would just rewrite it as u squared minus 8u plus 15. Factor that, u minus 3, u minus 5, and then you'd say, oh wait, they weren't really u's, they were x squareds. Okay, it's a substitution. I know it looks like a quadratic and talks like a quadratic. I can't get past the fact that there's x to the 4th there, so I'm going to temporarily change it to something squared. This form is going to come in more important in chapter 3 when we're dealing with exponential equations. Okay? Because then you're going to get stuff like e to the 6x minus 8e to the 3x plus 15. Okay? You're going to start getting stuff like that in chapter 3. So the U method is going to be handy. Are you okay with just going straight here, though? Okay. So from there, you get a choice. You can set each equal to 0 and solve. If I say x squared minus 5 is 0, x squared is 5, so x is plus or minus root of 5. Or, do you remember difference of squares factoring? In difference of squares, if I had something like x squared minus 9, how would I factor that? How would I factor it? The difference of squares is conjugate pairs, plus minus, square root of each, plus minus. Okay? So I can still do that here, just like this would be x plus 3, x minus 3. I can do it here as x plus root of 3, x minus root of 3. It still works even if the thing isn't a perfect square. Okay? So you choose. You can factor the first part and then go to solve by square roots, or you can continue factoring by difference of squares. In either case, you get x is plus or minus root of 3, plus or minus root of 5. I want you to put that in your calculator. Put the original equation, x to the fourth minus 8x squared plus 15, put that in your calculator and go calculate the zeros for me. Oh, I missed the 8. There we go. There we go. When you go to calculate those zeros, this is where I wouldn't manually move Blinky around. I would just press buttons instead. That looks like it's between 1 and 2. So I will calculate a 0 somewhere between 1 and 2. Mm-mm. You do math for real instead of relying on the calculator to do everything for you. The calculator will not give you simplified radical answers. So when you see that, you got to know that that is an irrational number. If that's an irrational number, that means you have to solve by actually doing math instead. If you tell me 1.73 instead of square root of 3, you're getting something off. Okay? If it's supposed to be the square root of 4 and you put 1.41, you're getting points off. Okay? We are big kids. You're going to write things in simplified fractions, simplified radicals, simplified compound and complex numbers in terms of pi, I, and e. Okay? Okay. All right. So, same thing, except now, having reviewed that stuff about what quadratic form does, when I see that it looks like a quadratic, I'm going to start by factoring like a quadratic. It's just x squareds now. Factors of -4 that add up to -3 are -4, +1. Again, check the directions. They say to find the real zeros. I say, screw it, we need the practice. Find them all. If I were to continue with difference of squares, this can factor into what? X plus 2, x minus 2. Remember how we said x minus the 0 is my c's, or x minus c is my root? Tell me, x minus what gets me x squared plus 1? Or sorry, x squared minus what gets me x squared plus 1? Okay, you'd have to put a -1 there, right? The difference of squares is plus minus real conjugate pairs. The sum of squares is plus minus imaginary. It's x plus I, x minus I. And if you don't believe me, you come over here for a side quest, and you say x squared minus 4 equal to 0, x squared is 4, x is plus or minus 2. If it's plus or minus 2, I'll have plus or minus 2 as my c values in my factors. If I say x squared plus 1 equal to 0, x squared is negative 1 when I square root. X is plus or minus I. So if I is one of my zeros, x minus I is one of my factors. You have to do purple, then you can go blue-green or yellow. I don't care which way for now. Later, when we have to find all factors of a larger polynomial, like a quintic, where you have to factor by grouping, and then within there, you also have to do multiple forms of factoring, different squares, sum of squares, AC method. All right, now we're going to have to actually factor all the way. But for now, this is okay. All right, so in either case, whichever route you took, we're going to get the possible real zeros was 4. The possible turning points was 3. Now we said those are the possible ones. It turns out the real zeros are just plus or minus 2. But if I want all the zeros, it's plus or minus 2. No, it's not a brownie point. I'm about as coordinated as an inbred cat. That's why I said an inbred cat. I'm the cat that you drop from 2 feet up and it still lands on its head. Okay. So, they say to find all real zeros, you've got to understand that the plus or minus 2 are the real zeros, but I can still find all 4 of my zeros, my complex zeros, if I just understand I as a thing. Okay? Again, you have to do purple and orange, but whether you do blue and green or yellow, to find those final zeros, I don't care. Boop, boop. Go! All. We need the practice. We're going to find them all.
I'm not there yet.
What's that negative? Oh, I got my I mixed up. Hold on. Whoa, no. Yeah. Because you're going to have x squared plus 2. What? Yeah, sometimes you just got a brain fart. Oops.
How do you like split up x with it? Like how do you make it into two?
GCF. GCF. Take out an x first. That's all it is.
It is not harder, Lori. Be quiet, Sammy. Sorry, Sammy. Jesus, is this what it's like living with you? No. Oh, yeah.
Yeah. So it's supposed to be a coefficient of I, but sometimes it's hard to tell whether it's in or out. So if you write I root of 2, that's fine. That's fine. That's usually how we did it in Algebra 2, just to clarify that it's separate from the radical. But I'll take both.
Would you rather have me write I root of 2 or...
Okay, Jacob just asked that same question. Remember that square root of 2i is that's like the fancy pants way of writing it, because you should put your real friends before your imaginary friends. So it should be a coefficient of I. But we have a tendency to not be very careful when we're writing, and maybe we can't tell in which of those is the I in the radical or not. Right? Yeah. You've been in here all year and you didn't notice that?
No, but why is it like that?
Like, I'll write 2 plus square root of 2 like this. I don't know why. My hand just does its own thing. Yeah. So, if you want to write I square root of 2, I'm cool with that. We usually did it that way. See, okay, I am not doing this on purpose. And I did the exact same thing right next to Jacob. I just do it. I don't know why. So, okay. First one, x squared minus 6, x squared minus 3. I can do difference of squares. X minus root of 6, x plus root of 6. X minus root of 3, x plus root of 3.
We still have 6 more minutes.
Contestant 2, take out your GCF first. Then factor that into x squared minus 8, x squared plus 2. If you did those as maybe this time you did x squared is 8, so x is plus or minus square root of 8, you have to simplify it. Yes, you do. X squared plus 2 equal to 0. X squared is negative 2. X is plus minus root of 2i. Okay, so whether you go to factor town or solve by square roots, I don't care. It's the same thing. Y'all, you are squirrely as all hell. It's like the first 4 weeks was get some more caffeine. Why aren't you talking? And now all of a sudden it's shut up. Like, Oh, and then the 4 possible real zeros, 3 possible turning points, 5 possible real zeros, 4 possible turning points. Okay. State the number of real zeros. Same thing, but now they get negatives and they get gross.
I think we should play that one for tomorrow. Get some fresh.
Yes, we should, because
Wait, really?
no, because third hour is always a little bit behind. Yes. Stop there.
So I just had a good idea.
They're always just like one example behind. Yes. Stop. I will try to get through all the notebooks next block if you are turning in notebooks instead of just a packet.